Okay, so in this particular video, I'm going to look at the graphing by transformation portion of the test. So the first question is actually often considered probably one of the harder ones because I have a strange function. It is related to the square root of x, but the function f is this whole thing. So I wanted to figure out, like, how could I take this thing and flip it across the x-axis? So remember, if you're going to take something and flip it across the x-axis, that's going to flip it this direction. All I need to do is I need to put a negative in front. So all I would have is the original function with a negative in front. Now keep in mind, one thing that I'm trying to get you guys to do a lot of is check your answers. So my original function was 2 square roots of x plus 3. And what I did is I just put a negative 2 in front, and let's just see what happens. So if I hit zoom 6 to go to a normal window, my original function looks like that, and here comes my new function, which should be the same thing flipped upside down. And I think you could see very quickly that all I did is I have this guy sitting on top. The new one is perfectly flipped over underneath. That seems appropriate. Now, similarly, if we're going to reflect something across the y-axis, we're actually going to be flipping it this way. So what happens is, instead of putting the negative on the outside, this one actually puts it on the inside. So according to our rules of composites back from Algebra 2, this says go rewrite function f, which is 2x plus 3, but we're going to take what used to be an x and we're going to put a negative x in that place. Now, again, like I said, that's a little strange, but let's see what happens. Let's look at our graph right here, trying to see if I can make everything show up on the screen. But here's my original function. So what happens if I insert a negative right here? Now, we already know what the original graph looks like. I'm going to hit enter so I can pause it. Notice it's scrolling because I hit enter and I made it pause. So if it reflects across, this point should come over here. This part that's coming this way should go that way. And there it is. You'll notice that it's a perfect reflection this way across the y-axis. Now, quite a lot harder question is these last two. If we are going to stretch something horizontally, horizontal things affect x. And we're going to stretch it. We're going to make it bigger by 3. But remember, things on the inside do the exact opposite of what we say. So instead of multiplying by 3, which would actually compress it, we're going to divide it by 3. So my final answer, I would replace x with 1/3 x, and that would actually have that ability to stretch it out. Now, again, a little bit harder to see this one, but if we insert a 1/3 right here, let's just see what actually happens. So it should take that thing, here's my original function, and it should stretch it. Uh-oh, I made a mistake. Oh, there's an extra parentheses there, that's why. So here's my initial function, and notice that the 3 was here, it got pulled way over here, and it got just elongated sideways. And last but not least, if I want to reflect something across the y-axis, just like what we did right here, I need that negative, and then I need to move it to the left too. And so keep in mind, that feels a little bit awkward, but remember, nothing should be attached directly to x when we think about it in this way. So I'm going to rewrite my original function 2x plus 3, but the x that I had is going to be replaced specifically with negative x plus 2. But that feels a little awkward to me, so I think I would probably distribute the negative to the x, distribute the negative to the 2 as well, and I end up with the following results. Now, if you did want to, you could, of course, in each of these problems, choose to factor a little bit more. We could factor this one as a negative and an x minus 1. You know, it's all good. We could do those things, but either one of these answers would be legit. And okay, so the last part, question number 4, talking about that, remember, everything on the outside affects the y value. So if that is the case, then this y value is going to be at 25. Everything on the outside affects the y value, so that means this is going to be a positive 3. Nothing is happening on the outside on this one, so it's going to be the number 2. So there really isn't a whole lot to do in those portions. But when we move on to the x, remember x is opposite land. We do the opposite of what it says. So we're going to add 2 to the x value, and I'm going to get 0. Over here, we have the unfortunate thing that something was attached to x, so we're going to factor out the 1/2, and half of 4 is still 2. So what we're going to do is we're going to double the x and get 8, and then we're going to go to the left 4, which gives me 4. So that should be 4 comma 2. And then last but not least, if we factor this one out, we'll factor the -3 out, leaving x minus 4. So we're going to take that x value, we're going to divide it by -3, which gives me -5, and then we're going to add 4 to that, which is going to give me the number -1. And that ends our little journey about graphing by transformation, problems number 3 and 4. I'll see you back for the next one. Bye-bye.